To find the volume of a sphere, we can use a result on page 10 of the formula book. It states that the volume V of a sphere with radius r is V is equal to 4 over 3 times pi times r to the power of 3. We are told that the sphere has a radius of 0.3 centimeters, so this should be our value of r. Let's sub this into our formula. Performing the calculation on the right-hand side gives us 0.113097. We need to give our answer in centimeters cubed correct to 3 decimal places. Rounding this off gives us our final answer that the volume V is 0.113 centimeters cubed. We are told that each centimetre cubed of pure gold weighs 19.3 grams. We can formulate this in an equation by stating that 1 centimetres cubed of gold is equal to 19.3 grams. In the first part of the question, we found out that the sphere contains 0.113 centimetres cubed of gold. So, how many grams does this correspond to? Well, our amount of gold has changed from 1 centimetre cubed to 0.113 centimetres cubed. In other words, it's been multiplied by 0.113. The grams will be scaled in the exact same way. So all we have to do is multiply 19.3 times 0.113. This gives us an answer of 2.1809 grams. Since we need to give our answer correct to 2 decimal places, we should round this off to get a final answer of 2.18 grams. We are told that there is approximately 6.02 times 10 to the power of 23 atoms in 197 grams of gold. We can formulate this in an equation as follows. 197 grams is equal to 6.02 times 10 to the power of 23 atoms. In the previous part of the question, we figured out that our sphere contains 2.18 grams of gold. So the question here is how many atoms does this correspond to? Getting from 197 to 2.18 directly is a difficult task. It's not immediately obvious what the scaling factor should be. To make things easier, we can find what 1 gram corresponds to as an intermediate step. To get from 197 to 1, all we need to do is divide by 197. Dividing the grams by 197 will also divide the atoms by 197. So the number of atoms in 1 gram will be 6.02 times 10 to the power of 23 divided by 197. This gives us 3.0558 times 10 to the power of 21. Now, to get from 1 gram to the target of 2.18 grams, all we have to do is multiply by 2.18. The number of atoms will scale in the same way, so this should also be multiplied by 2.18. When we perform this calculation, we'll get 6.6616 times 10 to the power of 21. We need to present our answer in the form a times 10 to the power of n. Our answer is already in this form. the A corresponds to the 6.6616, and the 10 to the n corresponds to the 10 to the 21. However, we need to write A correct to two significant figures. In other words, we only want to keep two non-zero digits. The first non-zero digit is the 6 before the decimal place, and the second non-zero digit is the 6 after the decimal place. And this is all we'll want to keep. However, since the next digit, 6, is greater than or equal to 5, we'll need to round upwards. This brings us to our final answer of 6.7 times 10 to the 21 atoms. The key to solving this question is the fact that the margin of error is 1 divided by the square root of n, where n is the sample size. In this question, we have a random sample of 1,560 viewers. So the sample size, n, is 1,560. Subbing this in, we see that the margin of error is 1 over the square root of n, which becomes 1 over the square root of 1,560. Typing this in our calculator gives us an answer of 0.025318. We must give our answer as a percentage. To convert from a decimal to a percentage, we multiply by 100. Another way to think of this is that we move the decimal point 2 slots to the right. So, as a percentage, our answer is 2.5318%. We need to present our answer to one decimal place, so rounding off gives us our final answer of 2.5%. This question involves calculating a 95% confidence interval. This can be broken down into a number of steps. The first step is to calculate the sample proportion and margin of error. In our survey, 546 of the 1,560 viewers said that they liked the show. To find our sample proportion, we just need to write this as a fraction. 546 over 1,560. In the first part of the question, we found that the margin of error was 2.5%. It's a bit awkward having the sample proportion in fractional form and the margin of error in percentage form. So let's convert the sample proportion into a percentage. Using our calculator, we can rewrite 546 over 1560 as 0.35. To convert from a decimal to a percentage, we multiply by 100. So this becomes 35%. We are now ready to start calculating the bounds for our interval. The lower bound of the interval is the sample proportion minus the margin of error. Here, that's 35% minus 2.5%, which is 32.5%. The upper bound of the interval is the sample proportion plus the margin of error. Here, that's 35% plus 2.5%, which is 37.5%. It is conventional to present our interval as follows. We write the lower bound and the upper bound separated by a comma, all enclosed in square brackets. So here, the 95% confidence interval is 32.5%, 37.5%. In this question, we must conduct a hypothesis test at a 5% level of significance. This procedure can be broken down into a number of steps. The first step is to state the null hypothesis, H0, and the alternative hypothesis, H1. In our scenario, the executive claimed that 40% of the viewers liked the show. Usually, the null hypothesis will involve equality and will correspond to whatever claim is being made. If we let P represent the percentage of the viewers that like the show, the executive is claiming that P is equal to 40%. This will be our null hypothesis, H0. The alternative hypothesis, H1, will involve inequality and usually corresponds to the claim not being true. Here, the alternative hypothesis, H1, is that P is not equal to 40%. The second step in our procedure is to create a 95% confidence interval for the data. Thankfully, we've already done this in the previous part of the question, and the 95% confidence interval we found was 32.5% to 37.5%. Step 3 involves the following. We need to look at the assumed value for the null hypothesis. If it is inside the confidence interval, then we fail to reject H0. If it is outside the confidence interval, then we reject H0 and move to H1. In our scenario, the null hypothesis states that P is equal to 40%. So the assumed value is 40%. This value is not contained in our confidence interval of 32.5% to 37.5%. 40% is too big. Since our value was outside the confidence interval, we reject H0 and move to H1. The final step is to state our conclusion in the context of the question. Well, we rejected H0, the executive's claim that P was equal to 40%. Instead, we opted for H1, which stated that P is not equal to 40%. So our conclusion is that we reject the executive's claim and conclude that the percentage of the viewers who like the show is not 40%.